Hi friends, in this video we are going to learn about fast Fourier transform. Fast Fourier transform is an algorithm which is used to compute discrete Fourier transform within less time. That means it enhances the speed of discrete Fourier transform. So whenever we consider a discrete Fourier transform, it is denoted by x of k equal to summation 0 to n minus 1 x of n e power minus j 2k by capital N into small n for k equal to 0, 1 up to n minus 1 samples. So this is how we define discrete Fourier transform. Okay, this discrete Fourier transform has n complex multiples, n complex multipliers, okay, and n minus 1 complex additions for each k, okay. So it does n complex multiplications and n minus 1 complex additions. So why we need to go for FFT is that for DFT to solve a problem it takes big O of n square time for DFT. Okay, as we have already discussed in data structures, what is big O notation, what is big theta notation. This is the time complexity of a discrete Fourier transform, whereas O n log to the base n is the time complexity of FFT. Okay, for solving a problem this takes if suppose this takes 1 year, it takes few minutes. Okay, this is the reason why we go for fast Fourier transform algorithm, so that our DFT becomes simpler and it takes so much less time to compute the problem, because all the systems, all the processes which we are working in a computer are all digital and they work with high speeds. For that we need a method or a logic which can perform or which can solve a problem within few seconds or few minutes. Nowadays it's becoming like it's taking only millisecond or nanosecond for a problem to solve. So we need fast Fourier transform so execute that problem. Generally, whenever we consider this e power minus j 2 pi k by n term, we denote Wn is equal to e power minus j 2 pi by n. Actually this is called twiddle factor. Whenever you consider k here, it will be minus 2 pi by n k. So multiply by k. Okay. Now this twiddle factor has got some properties, two properties. First property is that complex conjugate property. Okay, that it tells that Wn of k capital N minus n is equal to Wn of minus k small n is equal to Wn of k n whole star. Okay, we'll see how this property is executed. Now consider Wn of k n minus n. Okay, place the same here in this substitute here, we get e power minus j 2 pi by n, okay, k times n minus n, right? Now you try to split it, e power j 2 pi n into e power j 2 pi by n into kn, right? Okay, n and n gets cancelled, and here we get e power minus j 2 pi, e power j 2 pi by n kn. This value is 1, so e power j 2 pi by n k times n. This can be written as e power minus of minus j 2 pi by n k n, right? This can be written as e power j 2 pi by capital N minus kn. Okay, now which is given by wn minus kn. That is what we have got here. Okay, this is how we get the first property by solving it. Now, as you know, this is the complex conjugate, so wn kn star gives wn minus kn. Okay, now we'll deal with the second property. Second property is wn kn is equal to wn k times n plus n wn k plus n times n. That means this shows wn k times n plus n is given by e power minus j 2 pi by n into k into n plus small n. This is e power minus j 2 pi k, n and n cancel, into e power minus j 2 pi k small n, this small n by n. This is 1. Okay, this gives me wn for kn. So I took this and I have got this. In a similar fashion, if I take this, I'll get this. These are the two properties of twiddle factor. Okay, in the next lecture we'll deal with how to solve or how to get the even and odd terms of decimation in time fast Fourier transform. That's all for this video. Thank you.